Hi, it's Jan Beta, and I finally built up the courage to continue working on the Amiga 3000T, which I made a whole series about already. But things went not according to plan in the last episode, and the sound, which had some issues, stopped working completely when I tried to repair it. So I'm going to take another look at that, and hopefully we're going to end up with the sound circuitry working again after this episode. We'll see. Here's the corner of the Amiga 3000T board that I did the repairs on. I suspected that it would be one of the op-amps, these two chips here. And yeah, after replacing one of them, which I suspected because one of them is responsible for the sound output after the low-pass filter, and when that was engaged, one of the channels just didn't work anymore. So I suspected the one that was responsible for that. And by the way, this fault occurred right from the start. So before I did anything to the board except for fixing the battery damage, this fault was already present. So I'm pretty sure it wasn't my recapping job that I did or anything else that I did to this board that caused the fault in the first place. I just tried to fix it. I replaced the op-amp, and yeah, we got some issues with the voltage supply, which is a positive 12 volts and a negative 12 volts supply for these op-amps. And yeah, the positive side cut out, basically. And then I removed the other op-amp because I thought maybe that was dragging the voltage down. And I also removed the little amplifier chip over here, which is only responsible for the internal speaker that the A3000T has. This circuit is a bit different from all the other Amigas. Yeah, it's the only Amiga I know of that has an internal speaker, and that's what this little amp is for. And when I removed all the chips, our voltages were back to normal. So hooray, I thought. We finally found the culprit. And I thought it would be the little amplifier chip, but it wasn't, because when I put new chips in there, the voltage was down again and we didn't get any sound output at all. So yeah, there were a lot of encouraging comments on this episode where I did the repair attempt, and most of them pointed me towards the power supply circuit for the two voltages needed for the op-amps, the positive and negative 12 volts, which is actually pretty common to fail if you do something which I presume I did, and that was poking around with an oscilloscope probe and shorting out one of the voltages and blowing a little capacitor or a little resistor. We're going to look at the circuit diagram, and I'm going to explain or try to explain what I think might be causing this fault. Because the chips, I think, they came from a reliable source, and I think they are alright. The rest of the circuit probably is alright, but it might be that a resistor blew or a capacitor gave in or something is not making good contact. I'm going to show you the power supply circuitry for the audio circuitry. Let me take a few seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They can also do CNC machining, 3D printing, sheet metal fabrication, injection molding, basically everything the tinkerer needs. And they are currently celebrating their 12th anniversary. So they have a lot of discounts and some mini games and some special circuit board colors, including matte black, pink and purple, are free at the moment. So you don't pay anything extra for the special colors if you order PCBs. I'm going to link to the 12th anniversary celebration site in the video description, and I highly recommend checking PCBWay out in general. Back to our Amiga. So here's the audio circuitry. This is Paula, the chip that generates the audio output, and we looked at this before in the previous episode with the two LF347 op-amps, and we have the LM386, that's the little amplifier chip that I pointed at, and that's connected to the speaker connector for the internal little speaker. And then totally separate from this in this circuit diagram, we have the actual power supply circuit. That's this one. And that supplies the plus 12. That's the whole rail here that goes to all of these op amps and amplifier chips, and the negative rail here. And the voltages from the power supply are actually okay. But as you can see, we have this little R403 in this circuit here. If that's broken, we won't get any positive voltage. We have a little capacitor here. We have an electrolytic capacitor that I replaced here, and the same on the other side. And that goes to our op amp here, and then continues on to the rest of the circuit. If this is broken, C409, this might also short out to ground, and C410, same. These are two little capacitors as well. So I'm going to try to check all these components and see if that fixes our voltage supply issue. And then I'm not sure if that also fixes our sound issue altogether. Maybe it will. I'm still pretty sure it must have been one of the op amps that was broken, and now there are new op amps in there. But yeah, you never know, basically. I'm going to continue troubleshooting. So this is what it looks like in the actual circuit on the PCB. And yeah, I think I checked all these little resistors here and these capacitors, but there are some more here. It's actually not really clearly laid out which thing points where. And these are towards where the power actually comes from, where the power rail is. So I thought this would be what to measure. And these are all okay, as far as I can tell from last time. It's been a while. But then there's R403 over here. And yeah, it's not really clear. The writing is not very obvious on some of these components. But R403 is this one, and it's brown, black, gold. Gold, that's a 1 ohm resistor, just like it should be. And the other supply rail is actually here, I think. That's the other brown, black, gold, gold. That's another 1 ohm resistor. This is the one for the negative, and this is the one for the positive supply. And yeah, we're going to start measuring these, I think, and also the other little capacitors here, as far as I can in circuit, but you can usually at least tell if they are shorted. So that would be the thing that might cause one of the voltages to go down. My money is on the resistor here, though, at this point. That's my multimeter set to ohms. And we're going to check the supply for the negative rail, which was okay. This should be 1 ohm. Yeah, very close to 1 ohm. And then we are going to check R403, which is the one that should also be 1 ohm. Yeah. It's going down because the capacitor is charging up. But this is nowhere near 1 ohm. This is 420 kilo ohms. So yeah, this might be the whole thing that pulled our voltage down. Yeah, that might very well be the whole issue here. Because yeah, that's a couple hundred kilo ohms, 420 I think it was. And in case you don't have any extra load hooked up to that voltage rail, which is supplying these chips, if you remove the chips from the equation, the voltage was good, actually, or kind of a little bit low, but still in spec. And yeah, that might be the explanation, because if this resistor is going high resistance, you are going to get a low voltage as soon as you put a load on that voltage rail, which is what happened. So that might be the explanation for that. Yeah, no idea why I procrastinated this for so long. I think it might just be this little resistor. I have an idea why I procrastinated this, because I really don't want to mess this up. And I was a bit afraid that I already did after the previous episode. But I don't think I did at this point. Let's replace the little resistor and see if that fixes the issue. The R403 resistor is what we're going to replace, and I'm going to use my low melt solder trick that I used last time. This really helps on boards like this where you have multiple layers. Yeah, I need a bit more on that side, I think. There we go. Okay, just double checking this actually shot. Yeah. It's going up too. Yeah, that is very high for a 1 ohm resistor. Goes up into the mega ohm range as well. So no, that wouldn't transport a voltage too well. And as it so happens, I stocked up on 1 ohm resistors actually a while back. I used these for at least 2 other Amiga repairs. Yeah, that's 1 ohm. So that goes in there. And then maybe the whole thing works again. We're going to see. I have my rather precarious construction set up here again. And I think I need a mouse. So I have my rather precarious setup set up here again with the power supply. The power switch is needed to power the system, and it's also connected to the little key switch, which needs the key to power on and to be able to use the mouse and keyboard. Connected my mouse, and yeah, fingers crossed, this fixed our problem. I have also connected a GoTech here to run the diagnostics. Let's see what this does actually, if it blows up or if it still powers on. Still powers on at least. And it booted the Amiga test kit. Let's see if our audio test works now. We have sound again. Yeah, we have sound again. And with the low pass filter off, we have both channels. You can't hear it because I'm recording this in mono, but trust me. And when I turn on the low pass filter, the right channel gets very dim. So at least we fixed the problem of not having sound at all, I guess. That's something. But yeah, didn't get much further than that yet. So we're going to have to investigate a bit further, I'm afraid. I was so hoping that I fixed this problem. But yeah, I'm going to have to look into this a bit deeper because it's back to where it was basically. Sound works unless you engage the low pass filter and then it stops working on the right channel. It doesn't completely stop working, but it's very faint. Yeah, that sucks a bit. We're back to square one basically with the sound. It's a couple of days later and I looked into it a bit deeper and I printed out some circuit diagrams and I think I'm able to explain how the filter itself works now, and also maybe I'm going to be able to fix the issue. Possibly. Let me explain how the filter works. So yeah, we looked at this before. This is our low-pass filter section basically. This is the actual low-pass filter. These two resistors and this capacitor. This is our MPF 102 transistor. That's an N-channel JFET, and that switches this part of the circuit, the actual filter, in and out of this signal path here. So we have our signal coming from here, and this transistor gets -12 or +12 volts on the gate actually. And that switches this transistor into two modes basically. One mode is it just lets the signal pass through, so this basically becomes a short. So the signal goes from pin 8 on this LF347 over here and gets into the other op-amp in the LF347 basically. And if the transistor is switched to the other position where it doesn't conduct the signal through, the signal chooses the shortest path and goes through the resistors and through our capacitor. And this is just a simple RC filter, RC low-pass filter. 10K resistors here in parallel. That makes it a 5K resistor basically for the circuit, and a 6800 picofarad or 6.8 nanofarad ceramic capacitor in this case. And that then passes on to the LF347 and goes to the other LF347 over here. So that is our filter, and this is switched by this transistor. It's, yeah, basically as easy as that. And we have -12 or +12 volts on the gate of the transistor here. And that's actually coming from the cutoff signal, which is issued by the CIA. And I think what's at fault here is maybe the transistor, because maybe it doesn't stop conducting fully when it's switched off. That might be the case, so the signal gets messed up kind of. Or one of these components is bad. So the resistors or the capacitor and the low-pass filter is not working as intended and filtering too much or something like that. It sounds like the signal is lower volume and much darker, so more bassy. So it's maybe the filter is filtering out too much of the high frequencies. That might be caused by the capacitor going bad, maybe. I don't know. We're going to figure that out. I already checked the connections, and the voltages on the transistor are also switched actually. -12 and +12 is what's I measured at on this resistor 435 here. And there's -12 and +12 present. We're going to look at that in a second. And yeah, this is maybe what's at fault here. The transistor, the resistors, or the capacitor, I would say at this point. So let's check that. And it's not too easy to find those components because, yeah, it looks really nice in the schematics, but things are a bit more spread out on the board. I'm going to turn this on and show you the switching voltage at least for the transistor. Yeah, the switching obviously works because we get some kind of different behavior when we toggle the filter. So that's probably not the problem, but it might still be that the transistor misbehaves in some way and just lets voltage pass while it's supposed to block the voltage. Okay, started my music test here. Not sure if you can see the multimeter. You should probably be able to see it. Yeah. I'm now measuring the voltage on, what is it, R435. That's the switching voltage for the transistor. Currently the low-pass filter is on, so it's -12. Switching that off. And it's +12, or thereabouts. That should be enough to switch the transistor. And actually the sound cleared up. The switching voltage is there. We just saw that. What else can we check? The resistor values maybe. Okay, this is going to be a bit tricky to film, but our resistors are here and here, two 10K resistors. And they should both read as 5K, I think. Yeah, because they are in parallel. That's basic electronics. Yeah, that's across both of them, 5K. And if I measure them individually, they also show as 5K, but they are probably okay. Let me see if I can measure the capacitor in some way or the other. I don't really think I can, because this is not a good capacitor measurement device. Which one is it? C431. C431 is this one. And yeah, the multimeter kind of craps out. It looks to be alright, but it might have the wrong capacitance that I can't really measure in circuit. I also tried my better capacitance and ESR meter, and that doesn't like to measure this thing in circuit. That's what we're measuring here. C431. That might be our culprit, or of course the transistor here, Q430. Our resistors for the RC filters seem to be alright. I think I want to pull that capacitor and check it, and maybe just replace it and see if that helps. Yeah, I can't really test the transistor in circuit, so we might pull that as well. But I think I'm going to try the capacitor first, because the sound changed in a way that might hint towards the filter being at the wrong frequency. So maybe the capacitor got damaged. And these ceramic capacitors, they fail sometimes. Okay, we're just going to remove the capacitor. Not sure if it's broken at all, but worth a try at this point. There we are. Just jumped out at me. Let's see if we can check this outside of the circuit. I kind of doubt it, but we'll see. Multimeter into capacitance mode. And see if we can see anything here. Not sure. This is probably too small of a capacitor. It does do something. It's 0.26 microfarads. That would be a bit too high. So maybe this is the whole issue. But I'm not sure if this is measuring accurately. Let's try my other capacitor measuring device, which probably is not made for measuring tiny ceramic capacitors either. But we'll see what it says. Open circuit or low capacitance. Yeah, that's what I thought. I think this is just too small for this. This is meant to measure things in the microfarads range. Not sure if that is anything to go by, but I'm still going to just put another capacitor in there and see if that changes things. I didn't find the exact form factor. These actual ceramic capacitors, I don't know where to get them. If you have a good source for those, they are needed for a lot of retro computer things, but didn't find a good source for them. So I have kind of like standard capacitors here. Electrically, it shouldn't matter. And these are the correct capacitance. And rated at 50 volts, I think. So should be plenty for an audio signal. Yeah, 6.8. 682 is what they say. You really, really want this to work, as you can maybe imagine. Just double checking my connections here. Maybe this fixed the problem already. Otherwise, we're going to have to look at the transistor, which I ordered a replacement for. I'm not sure if it's in the letterbox already. Okay, let's see if that made a difference. It doesn't look too bad in there. At least it's the same color as the other ones. Okay, sounds fine with the filter off. Still sounds super muffled with the filter on. Yeah, exactly the same as before. So I guess it might be the transistor that failed in some way, or something I didn't see yet. We're going to have to figure that out. Good news, everyone! I just checked my letterbox. That's why I'm a bit out of breath. I'm at the third floor here. And the transistors are here, so we can check that as well. I'm just going to desolder the old one and put a new one in. These should be good. Came from a quite reputable electronics seller, so I think they should be good, hopefully. Just going to remove the old one and put one of these in and see if that changes anything. Otherwise, I am a bit out of ideas, but we'll see. Worst case, we don't have proper sound on one channel. That's not the end of the world, but it would be, yeah, not great. So let's try to fix this. Yeah, that's basically just falling out. There we go. MPF 102. Yeah, let's see. Maybe that helps. Just going to put a new one in there. Let's try again, I guess. Okay, fingers crossed once again. Let's see what we got. Okay, filter off works. Filter on, still the same thing. Still the exact same behavior. Back to the drawing board. I just realized I might have replaced the wrong capacitor. This one says 224. It's not 6,800 picofarad. Yeah, that might have been the wrong one. So the question is, where's the correct one? It says C431 next to the one we removed and replaced, which should be the one responsible for this, but it might refer to another one. I think there's another 68 capacitor over here that doesn't have a designator. Maybe that's the one. But the connection's checked out, but that might just be a coincidence that all these capacitors are connected to the same things. No, I think that's the correct one. But it was a completely different value. That is very strange. Yeah, I'm not sure what that's all about. I'm going to have to look at the schematics again, I guess. That is kind of confusing. I'm not finding the capacitor on the board, actually. So this says C431 underneath it. That's the one we replaced. But I think that's the wrong value because it doesn't have the correct value on the capacitor we removed. And there's another 6.8 nanofarad one here that doesn't really seem to have a designator, so maybe that's the one we're looking for. And this was 2.2 or something. I don't remember what it said. 22.4, I think. Yeah, so this is the wrong one. And there's another 6.8 here, I think. So I'm going to look up the schematics again for the other channel. If this one is not for the left channel, this one might be the one for the left channel. And we might have to replace this one, actually. But it's kind of strange because the connections, this should be connected to pin 7, which it is, actually. C431. This is pin 7 on the op amp, and that's what this capacitor is connected to. So that should be okay, really. That should be, according to the schematics, that should be the capacitor that's responsible for the filter. I'm not sure. I'm going to have another look at the schematics and see what the other capacitor is for the left channel. Yeah, it is the correct capacitor that we replaced. It just had the wrong value from factory, it seems. Or at least the wrong value according to the plan. This should output to pin 7 and pin 6 on the op amp, and it does. And the other end should be connected to our resistors, which it is. So that's the correct capacitor here, but it had this one in there, which is a 0.22 microfarad one, 224 capacitor. That is really strange. So this is clearly the capacitor that forms our filter with the resistors, and it goes to the correct pin according to the schematics. And the other 6.8 nanofarad capacitor, that is actually C441, and that does the same for the other pair of resistors, R441 and R442, that's for the left channel. And that is connected to other pins on our op amp here. Yeah, that should be correct. So why did they put the wrong capacitor in that position? Why didn't changing the capacitor value fix our filter issue here? Maybe they put another wrong one in there somewhere? I think that's just the wrong... The other one clearly is a 6.8 nanofarad one. That is the correct value. And that's the same circuit otherwise for the filter. It's exactly the same circuit for the left channel that it is for the right channel. And I'm not sure why this didn't fix our issue, because clearly that's the filter section here, that we put a correct capacitance value in. Yeah, I'm not sure why that is and why it doesn't change anything regarding the sound output. It should be the exact thing that we need, really. It might still be the resistors, but yeah, they are the same on both, I think. And they measure 5K. Just let me double check this. Yeah, it's exactly the same on the other channel. 5K all along, because these are two 10K resistors in parallel. It's exactly the same circuit now, with a slightly different looking capacitor in there that I put in there. The switching works, but we still get the muffled sound. Maybe it's another capacitor that's faulty? I think there's another one in the circuit. Let's see. So back to the drawing board, or in this case, the printed out schematics. We replaced this one, which was a 0.22 microfarad one. For some reason, we replaced that. And that's definitely the one we replaced, because I measured this end here, and that goes to pin 7 here, and is also connected to pin 6 here. So this is what we replaced with the correct value according to the schematics, which of course might be wrong as well. But on the other channel, this is exactly the same, and that capacitor is in there, and that says 6,800 picofarad actually, and that is, yeah, that's the same circuit. Two resistors, one capacitor, that's our filter circuit, and the same MPF 102 for the left channel. Yeah, and I replaced this one, which also is it seems to work fine. The switching does work. We have in this circuit here, going in here, we have another capacitor, 3900 picofarad. I'm not sure how this would affect the filter, because once you turn the filter off, the sound is fine. Maybe this becomes part of the RC filter as well. Might want to take a look at this just to double check. And otherwise, yeah, this all affects the whole signal basically. So this can't really be an issue, the stuff that comes after this LF347. It's only the filter that doesn't really work. So the only things I can think of at this point would be the resistors acting up in some strange way that I can't measure. Or this capacitor, maybe. Maybe I'm just going to replace this capacitor if I can locate that. That's C432. I don't know why this was another value then in the schematics. I have no idea, but this clearly is a 0.22 microfarad capacitor originally, and it should be a 6.8 nanofarad capacitor, which is a different thing, completely different value. So looking for C432. That should be connected on one end to pin 5 of the LF347 op amp, which should be 1, 2, 3, 4, 5. This should be pin 5. So this might be the one we're looking for. That's a 3.9 nanofarad capacitor, or 3900 picofarad, according to the schematics. I'm just going to replace that, I guess. Maybe that's broken. Can't think of much else, except for the resistors, but I measured those a few times now, and they measured fine. But it might still be something to do with the resistors, so that's the next thing, I guess. So just marking this one, which should be the third one in this row here. I'm not sure if I'm interpreting everything right, but yeah, I do think so. Just rebuilding the whole thing here. That says 104. What is going on? Maybe they just populated all these with the wrong capacitor values. That's clearly C432, and that's supposed to be the one for our filter. That goes to pin 5 on the chip, yeah. Maybe they just put some wrong capacitor values in there. I'm not sure at this point. This clearly is the correct capacitor according to the schematics. And I have some 392 is what's supposed to be. We're going to look at the one for the other channel in a second, I think. Just to make sure I'm not going completely bonkers here. This is kind of strange. I think, at this point, I think the filter did never work correctly on this machine. If those are the capacitors that were in there. And they were, they were clearly in there. Just took them out. So far, we didn't get any change in the behavior, so I'm not even sure if I'm poking the correct thing here. So, another capacitor replaced with the value that's actually specified in the schematics. Okay, I'm just going to try again. Capacitors in there, looking as you'd expect, a bit different. Let's test again. I think it might be working again. Yep. Yes. It's working! What? Why did they do that? They just put completely wrong capacitor values in there. It's working absolutely fine now, with the filter on and off. No problem whatsoever. I don't know if you can hear it properly over the noise that the fan in the power supply makes, but it's working! We fixed it! And it appears, as I said, I think this didn't work from factory. I think this was a factory fault introduced by Commodore. Back when they made this, they populated 2 capacitor positions wrong. Yeah, that took me a while to figure out, of course. But yeah, the schematics seem to be alright, and now everything is just back to working condition. The filter is filtering, but it's not filtering too much, which I think is what happened before. It just cut off the high frequencies way too low in the frequency spectrum, so everything got muffled and the volume was pretty low because there was not much left that wasn't filtered out. It works! Yeah, nothing was broken really, just 2 capacitor values that were completely off. From factory, it seems. I don't think anybody ever worked on this before I did, except for putting some RAM in and things like that, but yeah, that couldn't cause the wrong capacitor value being populated on the board. Yeah, I know that these were pretty low volume. They didn't make many of these, and I hope they didn't do this on a number of these. So maybe if you have a 3000T, which yeah, not many of you have probably, maybe you can check if your low-pass filter works correctly on both channels. Mine clearly didn't. And I found the cause. I replaced many components before I found the cause, because I didn't have wrong capacitors from factory on my list. Huh. What the heck? Commodore. Maybe you should have stuck with making telephones. Yeah, that was kind of an adventure, but eventually I figured it out, and you were my witnesses that the capacitors were actually wrong from factory. And now we have some socketed chips, which doesn't hurt, I guess, a new transistor, and some capacitors that are actually the correct values. And the schematics seem to be absolutely okay. So yeah, that's what it was. 2 capacitors that were absolutely off. I hope you enjoyed this episode. There are going to be more episodes about the Amiga. There are going to be more episodes about the Amiga 3000T, obviously. I can't wait to put it all back together and work on the other components, because this takes up a lot of space in my very small lab here. There may be some episodes in between, because I am not going to work on the 3000T all the time. I hope you understand. But there are going to be episodes about this. I want to fully refurbish this now that it hopefully completely works. We're going to do some more tests and work on the case parts and put some new fans in. I already have some. Yeah, that's the next steps. The next video is probably going to be a C64 video again, but then I'm going to continue working on the Amiga eventually. So hope you can wait for a bit longer. That's it for today. I hope you enjoyed this and maybe you learned something. I certainly did. Special thanks, as always, to my supporters on Patreon and on Ko-fi and on the YouTube channel memberships page and elsewhere. The links to the support stuff are on my website and in the video description, in case you want to give me some support and help me buy more op amps and capacitors and things like that. Things add up. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye. And also, don't forget to subscribe to this channel. Stay tuned for more Amiga 3000 Tower episodes in the future.